Alrighty. So again, the review or an overview of the autonomic nervous system. The two branches, first is the parasympathetic nervous system. Second is a sympathetic nervous system. In the parasympathetic system, you have your pre-ganglionic neuron, your post-ganglionic neuron, and receptor sites. Same with the sympathetic system. You have the pre-ganglionic neuron, the post-ganglionic neuron, and its receptor sites. When I say receptor sites, as you've learned, each neuron releases a neurotransmitter. The neurotransmitter does not cause the effect. The effect is based on the receptor site that neurotransmitter lands on. We'll get to that in just a second. So let's look at the parasympathetic nervous system. The preganglionic neuron is cholinergic. The reason it's cholinergic, it releases acetylcholine. So acetylcholine is the neurotransmitter. The one thing both the parasympathetic system and the sympathetic system have in common is both the preganglionic neurons are both cholinergic. Which means they both release acetylcholine. When they begin to differ, it's a post-ganglionic neuron. In the post-ganglionic neuron, this is still a cholinergic fiber. Therefore, it still releases acetylcholine. Now, acetylcholine has two receptor sites. One is called the muscarinic. The other is called the nicotinic. Both are primarily excitatory. Nicotinic is more faster reacting than muscarinic. So if you have the acetylcholine come across the synapse, to the receptor site, nicotinic or the muscarinic be the ones that receive this acetylcholine. The receptor site now causes the effect in the cell. What the actual effect is will differ, but regardless of what the organ system is, if you have acetylcholine released, receptor sites will be either muscarinic or nicotinic. And what type of a response will they support? Rest and digest. They come right back here to rest and digest. So although let's say the muscarinic may have different type of response in different cells, the result will always support the rest and digest. If you just remember that, it'll help you go a long way to remembering what they actually do. I'll give you examples, more clear examples down here. In the sympathetic system, the postganglionic neuron is an adrenergic neuron. And it releases norepinephrine, primarily. The layman's term is adrenaline. That's why I call it an adrenergic. And as the cholinergic had two receptor sites, adrenergic neurons have two receptor sites. They have alpha receptor sites and beta receptor sites. And what type of response will activation of either an alpha or beta result in? Fight or flight, exactly. So whatever they do, they're going to support the fight or flight response. Whatever the muscarinic does, it's going to support rest and digest. So let me give you a quick example. Let's say you have a beta receptor in the bronchial tubes of your lungs. If you're running a race or running away from a wolf spider, you need to get more air in your lungs or less air? More air. So do your bronchial tubes need to dilate or constrict? Dilate. Would the activation of betas then cause constriction or dilation? Dilation, because you need to get more air in. Exactly. So this actually supports the fight or flight response. Let's say the blood supply going to the tissues, to the muscles. Do you need more blood to the muscles or less blood? More. So if you have a beta receptor on the blood vessel walls, that causes those cells to vasodilate or vasoconstrict? Dilate. That's where you need the blood. If you have an alpha receptor on blood vessels in the gut, that causes the vessels to dilate or constrict? Constrict. So one causes dilation, one causes constriction, but what do they both support? The fight or flight, exactly.
Is that why when you exercise you should breathe in through your nose and out through your mouth because it triggers something?
No, that's primarily due to the air being warmed, moistened, cleansed. Okay, question about the overview of the autonomic nervous system. You need to be able to memorize this chart and know the ramifications. We'll get more specific what these receptor sites do later, but you need to be able to memorize this chart and do it by memory.